modern day deep learning applications, for example, for speech recognition, we have a lot of data that is available for the training. Whereas for the image recognition, even though as per the modern standards, we have much amount of data, but still that is not sufficient to properly recognize the image. And similarly for the object detection also, the data that is available for the training, that is very small, because in the object detection, we have to make a bounding box, and in this bounding box, we have to predict what is there, whether in this bounding box car is there or scooter is there, we have to predict. So if we have a very small amount of label data for the training, then we have to concentrate on the network architecture. Either we have to take a very deeper architecture, and we have to concentrate on hand engineering of the features. We have to make different changes. So we have to use a much deeper networks because we have a very small amount of data. At that time, we can even go with the existing networks, like we have nowadays we have the Resonate and a mobile V2. We can train, we can use the trained network, and we can get the output from that, from those networks. Example, we can use 3 to 15 networks as per the ensembling standards. Independently, we can train, and we can get the average of their outputs. When we are training, we can initialize the weights which were already established by those networks, or otherwise you can freeze the network and you can get the output, and you can average those outputs. The average of those outputs may improve definitely the accuracy. And there is another way, because we are using 3 to 15 networks, it may take computationally, it may costly. There is another way in which we are taking two images example, and these are the flipped images, horizontally flipped images. Now we are taking a 10 crop, this 10 crop classifier on multiple versions of the test images, and we are averaging the results. Example, what is this 10 crop? Example, we are cropping this image. This is where we are cropping. And similarly, the flipped image also, we have to crop in the same manner only, like that. And second, we are cropping this image at the edges, corners. So we are cropping this image at the 4 corners. So we will get 4 here, and this is 1. And similarly, we will crop this flipped image, and we will crop this flipped image also 4 times. So we are getting 10 crops. This is what we mean by 10 crop. And we use these 10 crops instead of, now we have only 2 images. Example, we have considered one image and we have copied that image, you can consider. So instead of using only one image for the testing, now we have 10 images generated from the same image because of this 10 crop method, and we can use those 10 images at the testing time in order to get a very good idea whether it is predicting properly or not. So we can start using the architectures of the published papers, and we can even implement, so we can even try to use the open source implementations, even the existing models. So where they have published, we can write the open source implementations if possible. That is secondary step. And we can use the pre-trained models whose weights are already trained. There is no need to train that model again for fine tuning for our data set. That may give a very good output, because they might have trained this model for many days or months also. We can use such type of model for our data set. If we are getting a very good results, then our problem is solved.